There is a version of you that can outrun a car, lift more than your muscles should allow, and stop bleeding faster than medicine can explain. And that version of you only appears in the presence of terror. Right now, in the amygdala, a small almond-shaped cluster of neurons buried deep in the temporal lobe, a threat has been detected before your conscious mind even knows what it saw. This happens in under 200 milliseconds. Before you can form the thought, "That's dangerous," your amygdala has already fired a signal to your hypothalamus, and your hypothalamus has already begun a chemical chain reaction that will flood your bloodstream with adrenaline. You are, quite literally, afraid before you know you are afraid. This is where the biology of fear meets something closer to physics than psychology. Scientists call this pathway the HPA axis, short for hypothalamic pituitary adrenal axis, and it operates with the mechanical precision of a relay system. The hypothalamus signals the pituitary gland. The pituitary gland signals the adrenal glands sitting atop your kidneys, and the adrenal glands release a cascade of hormones, adrenaline first, then cortisol close behind, into your bloodstream within seconds. This is not a metaphorical alarm system. It is an electrochemical circuit, and it is one of the fastest signaling pathways in the entire human body. Most explanations of fear stop at fight or flight and move on, as if that phrase explains anything at all. A doctor's appointment does not have time to walk you through what is actually happening in your vagus nerve, your platelets, your visual cortex, and your memory-forming hippocampus in the 10 seconds after you perceive a threat. A wellness article will tell you to breathe through your anxiety without ever mentioning that your breath and your fear response are wired into the very same nerve. Today we are going deeper than either of those ever go, mechanism by mechanism, until fear stops being a mystery and becomes something you can actually see. The first mechanism is the amygdala hijack itself. Your scientists studying fear conditioning, work reviewed extensively in the Journal of Neuroscience, have shown that the amygdala has a direct, high-speed connection to the sensory thalamus that bypasses the slower, more deliberate visual cortex entirely. This shortcut, sometimes called the low road, is why you can jump back from a coiled garden hose half a second before your conscious brain identifies it as harmless. Evolution built this shortcut because a half-second delay when the object really was a threat could be the difference between surviving and not surviving. Your brain would rather be wrong 100 times than be right too late even once. The second mechanism is the adrenaline surge, and this is where fear becomes something you can feel in your chest. Adrenaline, released from the adrenal medulla, binds to receptors on your heart muscle within seconds, increasing heart rate and the force of each contraction. Research from Harvard Medical School describes this as a full-body reallocation of resources. Blood vessels in your digestive tract constrict, which is why fear can make you feel nauseated or give you the sensation of your stomach dropping, while blood vessels in your large muscles dilate, preparing your legs and arms for a burst of movement that may never come. Your body does not know the difference between a genuine physical threat and the anxiety of a difficult phone call. It prepares for a sprint either way. The third mechanism involves your blood itself. Studies referenced by the American Heart Association have found that acute fear triggers a measurable increase in platelet aggregation, meaning your blood becomes temporarily more prone to clotting. This response evolved to protect you from bleeding out during a physical injury inflicted by a predator or a rival. But in a modern nervous system, one that experiences fear far more often from emails, financial stress, or health scares than from physical danger, this same clotting response can activate dozens of times a day with no wound to justify it. Over years, this repeated activation is one of the mechanisms researchers believe contributes to a small but measurable increase in cardiovascular risk associated with chronic anxiety and fear-based stress. The fourth mechanism is the freeze response, and this is the one most people misunderstand entirely. Fight or flight is only half of the story. Polyvagal theory, developed by researcher Stephen Porges and now widely referenced in trauma and stress literature, describes a third pathway called the dorsal vagal freeze response. When a threat feels inescapable rather than merely dangerous, The same vagus nerve that normally calms your heart rate instead triggers a dramatic drop in heart rate and blood pressure, sometimes producing the sensation of going numb, feeling detached, or being unable to move or speak. This is not weakness or overreaction. It is an ancient survival mechanism, the same one that causes a mouse to go limp in the jaws of a cat, a final biological strategy when running and fighting are no longer options. The fifth mechanism is what fear does to memory, and it may be the most important one for understanding why certain fears seem impossible to shake. The hippocampus, the brain's primary structure for forming new memories, works in extremely close physical proximity to the amygdala. And during a fear response, cortisol actually enhances the hippocampus's ability to encode that specific memory with unusual vividness and permanence. This is why people can often recall a frightening moment in extraordinary sensory detail decades later. The smell in the room, the exact words spoken, the color of the light, while ordinary memories from the same week have long since faded. Fear does not just happen to you. It edits your memory in real time, stamping the experience in ink rather than pencil. Here is a way to picture the entire system working together. Imagine your nervous system as a fire station and the amygdala as the alarm bell. The moment that bell rings, every firefighter in the building drops what they are doing. Adrenaline is the truck engine roaring to life. Cortisol is the extra fuel poured in for a longer response. Platelet activation is the protective gear being strapped on in case of injury. And the freeze response is what happens when the fire chief looks at the blaze and realizes it's already too large to fight, so the entire crew simply braces instead. None of this is malfunction. Every single piece of it is the station operating exactly as designed. The problem, for most people living in the modern world, is that the alarm now rings for things that are not actually fires. Emails, arguments, waiting rooms, the 6 o'clock news. This system changes in important ways as the body ages. Research published through the National Institutes of Health indicates that after the age of 60, the amygdala's baseline reactivity to certain threats, particularly threats related to falling, physical vulnerability, and loss of independence, tends to increase, even as reactivity to some social threats decreases. At the same time, the cardiovascular system's ability to recover quickly from an adrenaline surge becomes less efficient, meaning the heart rate and blood pressure spikes associated with a fear response can take longer to return to baseline in someone in their 60s or 70s than they would have decades earlier. The CDC has linked chronic, unresolved anxiety in older adults to increased fall risk, a finding that is almost paradoxical until you understand the mechanism. Fear about falling can produce muscle tension and hesitant, unnatural movement patterns that measurably increase the likelihood of an actual fall. The fear response, meant to protect you, can become the very thing that puts you at risk. And yet, after walking through 5 interlocking layers of neurology and endocrinology, the simplest actionable insight is once again almost laughably small. Research suggests that slow, extended exhalation, breathing out for longer than you breathe in, directly stimulates the vagus nerve and can begin lowering heart rate and adrenaline within about 90 seconds. You do not need to talk yourself out of fear, which rarely works because fear is not fundamentally a thought, it is a chemical state. You only need to give your vagus nerve a physical signal that the fire is over, and let the body's own mechanism for standing down take it from there. But here's what almost no one knows about what happens next. And it is the part of the fear story that changes everything. The amygdala does not just respond to threats. It learns from them. And it can be quietly retrained. A landmark body of research on a process called fear extinction, studied extensively in laboratories affiliated with institutions publishing in Nature, has shown that when a person is repeatedly exposed to a feared stimulus in a safe context, the amygdala does not erase the original fear memory. It builds a brand new memory pathway, essentially a second competing signal that inhibits the original fear response without deleting it. This means old fears never fully disappear from the brain's architecture but they can be functionally overridden by new experience, layered on top like new paint over an old wall. This is, in a very real physiological sense, the mechanism behind courage. Not the absence of fear, but a second pathway strong enough to compete with the first. Step back far enough, and every part of this cascade, the amygdala's quarter-second calculation, the platelets thickening in your blood, the memory sealed in vivid detail, is simply atoms following the laws of chemistry, the same laws that govern the burning of a star or the rusting of iron. There is something profound in the fact that fear, one of the oldest and most universal experiences in the animal kingdom, is built from nothing more exotic than sodium ions crossing a membrane and hormones binding to receptors. And yet from that simple machinery arises something as complex as the courage to face a diagnosis, an empty house, or an uncertain future. You are not broken when you feel afraid. You are running software that has kept mammals alive for 200 million years, and every single one of your ancestors, without a single exception, survived long enough to pass that software down to you. None of what has been described here is meant to replace medical or psychological care. If fear or anxiety in your life feels persistent, overwhelming, or connected to physical symptoms like chest pain or shortness of breath, please speak with a doctor. And organizations like the NHS and the CDC offer resources specifically designed to help. If this explained a feeling you've carried for years without ever understanding why your body reacted the way it did, send it to someone who needs to hear it. Understanding the mechanism is often the first step toward feeling less afraid of the fear itself. Because there is one more question hiding just beneath this one. What is actually happening in your body in the exact moment fear turns into hope? The chemistry is more surprising than you might expect, and it starts with the very same molecule we just spent 20 minutes describing as your enemy.